Whenever AB is defined for a given matrix, it doesn't make sense that BA also has to be defined. Whenever A and B are square matrices of same order, then the product AB can also be defined, BA can also be defined. So remember, you have 3 elements in a row and 3 elements in a column. That is why number of columns and number of rows must be same. Then only we can multiply the elements inside it. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In the previous session, we have learned the operations on matrices, that is how to add, subtract or how to multiply a scalar to a matrix. In this session, we will be studying about the multiplication of matrices. So let's study how to multiply any two matrices. So the multiplication of matrices or the product of two matrices A and B is defined only when the number of columns of the first matrix A is equal to the number of rows of the second matrix B. So here I have taken an example. First you have to see that whether the number of columns in the first matrix is equal to the number of rows in the second matrix, then only the product is defined. So here, what is the order of this matrix? 2 rows, 3 column. So it is 2 cross 3 matrix and here it is 3 rows, 2 columns. So clearly you can see here the number of columns in the first matrix is equal to number of rows in the second column. So this is how we define the matrix. Then what will be the order of the new matrix? The order of the new matrix is that, so whatever you have the column, just remove it. Remove the column number from the first matrix and the row number from the second matrix. Then the order of this matrix will be equal to 2 cross 2. So when you have two matrices A and B, the product AB is defined. The product AB is defined only when the number of columns of A is equal to number of rows in B and here columns in A. And the resultant matrix will be of the order 2 cross 2, that is M in the first matrix and N in the second matrix. Now, how to find out the product of two matrices? So this is the rule we see here. So this is the sum of first row into first column, sum of first row into second column, second row into first column and sum of second row into second column. So first let us write the two matrices given here. So here I have taken the matrix A is equal to 1, minus 1, 2 and 0, 3, 4 and matrix B as 2, 7, minus 1, 1, 5, minus 4. So these are the examples we have taken matrix A and matrix B. Now how to find out AB? So AB is first find out the product of first row and first column element. That is, this is the first row and this is the first column element. So multiply each corresponding value with it and make a sum of it. That is 1 into 2. So 1 into 2 plus, because here we have taken sum of first row into first column element. Next, minus 1 into minus 1. So, minus 1 into minus 1. Next, plus again because we have to take the sum and this is 2 into 5. So, this is how we define the sum of the product of corresponding elements in the first row and first column element. Similarly, we have to take sum of first row, second column element. Let's take first row and second column. So, first row, second column means it is 1 into 7 plus minus 1 into 1 plus the last element 2 with 4. So, 2 into minus 4. Now, this is done. That is sum of first row into second column element. Next, we take sum of second row, first column element. So, this is our second row here. So, take second row with first column. So, second row elements with first column elements. So, that is 0 into 2 plus 3 into minus 1 plus 4 into 5. Now this is done. So we have taken the product of second row with first column elements. Now the last one is second row with the second column elements. That is 0 into 7 plus 3 into 1 plus 4 into minus 4. So this is done now. There is no other columns left. There is no other rows left here. So now here, let's add this. This is 2 minus 1 plus 10. Here it is 0 minus 3 plus 20. Next we have 7 minus 1 minus 8. Next here it is 0 plus 3 minus 16. Now this is equal to, so 2 minus 1, 1, 1 plus 10, 11. And here minus 3 plus 20 is 17. 7 minus 1 is 6, 6 minus 8 is minus 2. Next 3 minus 16 we have minus 13. So this is the product AB. And what is the order of the matrix? Here you have 2 rows and 2 columns. So this is the order of the new matrix. What was the order of matrix A? It is 2 rows into 3 column, and this is 3 rows into 2 column. So remove, whenever the column number and rows number is same, then only we can define the product, and the order of the new matrix will be equal to 2 cross 2. So this is what you should know. That is, the product is defined only when the number of columns of the first matrix, you have 3 columns here and 3 rows here. So the number of columns in the first matrix must be equal to the number of row in the second matrix. Then only we can define it. That is, the product AB can be defined. And how to do it? That it can be done with the number of rows and number of columns here. For this example here, this is sum of first row into first column element will be the first element. Next element will be sum of first row into second column. So here you have 3 elements in each row and 3 elements in each column. So multiply the corresponding element and add it. So when you evaluate it, you will find the elements inside the matrix. So now, in the multiplication of matrices, there are certain terms and conditions which you have to note here. I already said the product AB is defined only when number of columns in first matrix is equal to number of rows in the second matrix. So here is the first point to be noted. If AB is defined, then BA need not be defined. So whenever AB is defined for a given matrix, it doesn't make sense that BA also has to be defined. Let us take an example here. We have 2 rows, that is 2 cross 2 matrix here, and this is 2 cross 3 matrix, 3 columns. So here, number of columns in the first matrix is equal to number of rows in the second matrix. So we can define the product AB. So that is AB, see, first row into first column. So multiply first row with all the columns. So there must be 3 elements. So therefore here 6 2s are 12 plus 9 7s are 63. So next we have to take first row into second column. 6 6s are 36, 9 9s are 81. Next first row with last column. 6 0s are 0, 9 8s are 72. So this is done now. Next you take second row with all the column elements. So second row first column, 2 2s are 4, 7 3s are 21. Next 2 6s are 12. Next 3 9s are 18. Next 2 zeros are 0, 3 8s are 24. So therefore AB is equal to here 12 plus 63, 75, 81 plus 36, 117, 72, 25, 30, 24. So this is how the product is defined. See here, AB is 2 cross 3 matrix. 2 cross 3 matrix. So just number of rows and number of columns are equal, then the resultant matrix will be equal to the rows. That is number of rows in first column cross number of column in the second column. That is 2 cross 3 matrix. You will get that as 2 rows and 3 columns. Now let's see about BA. So now you have seen that AB can be defined. Now let's see how BA can be defined. BA means B, that is 260798, and A is here 6923. So here, what is the order of B? Order of B is 2 rows, 3 column. What is the order of matrix A? 2 rows, 2 column. Clearly you can see the number of column in this first matrix is not equal to the number of rows in the second matrix. And also you can see here you have 3 elements, but you don't have 3 elements to multiply down. So therefore, that is number of column is not equal to number of rows, and hence we can multiply the matrices. So therefore, BA is not defined. So therefore, for all the matrices, whenever you can find or you can define the product AB, then it is need not necessary that it must define product BA also. So there exists a case where BA is not defined. Next point, if both A and B are square matrices of the same order, then both AB and BA are defined. Suppose if A is of an order 2 cross 2 matrix, and B is in order of 2 cross 2 matrix, then obviously however you take AB or BA, both are defined, because number of columns and number of rows in each time, that is either you take BA or AB, it will be equal to 2 only. Hence in those cases you can define product AB as well as product BA. Hence whenever A and B are square matrices of same order, then the product AB can also be defined, BA can also be defined. Next point, multiplication of matrices is not commutative. So I already said you AB can also be defined for a square matrix and BA can also be defined for a square matrix. But it is need not necessary that the product AB is equal to BA. So this is not possible for all the cases. So here I have taken an example of 2 cross 2 matrices of our matrix A and matrix B. So let's define AB. So first row into first column, 1 0 is a 0, 0 1 is a 0. Next 1 1 is a 1, 0 0 is a 0, 0 0 is a 0, minus 1. Next we get 0 0. So this is AB. So what is AB now? 0 1 minus 1 0. Let's see BA. BA means first you have to take B, first row into first column element, that is 0 1 is a 0 plus 1 0 is a 0. Next first row into second column, 0 0 is a 0 minus 1. Next second row first column, 1 1 is a 1 0 0, and here it is 0 0. See here BA is 0 minus 1 1 0. So you can clearly say the corresponding elements of AB and BA are not same. So the second elements are different and the third element you can see that is also different. So therefore, it is not necessary that the product of matrices is commutative. It is not commutative. So next point, zero matrix as the product of two non-zero matrices. So here I have taken two examples of non-zero matrices. Zero matrices are nothing but null matrices. So what does it states? Whenever you have two matrices A and B, and when you multiply it, when the values are equal to 0, that is if it is equal to the null matrix O, then it need not be that A is a zero matrix or B is a zero matrix. It is not necessary that both must be a zero matrix. So even though if it is a non-zero matrix, it can be zero matrix. That is, AB matrix can be zero, or the product of any two matrices can become a null matrix even though if A is non-zero as well as B is non-zero matrix. It is not necessary that one of the matrices or both matrices must become a null matrix. So this is what Here it says the product of two matrices is a zero matrix. It is not necessary that one of the matrices is a zero matrix. That is, if A is 1, minus 1, 0, 2, then B cannot be 0, 0, 0, 0 always. It can be a non-zero matrix also, such that when you multiply it, the resultant matrix can become a zero matrix. So let's take few problems now. Compute the indicated product. So here we have two matrices. What is the order of this matrix? So we have 3 rows and 1 column, and here we have 1 row, 3 column. Clearly, number of columns is equal to number of rows. Hence, you will get a matrix of order 3 cross 3. So remaining rows here and remaining columns here. So 3 cross 3 order matrix you should get. Let's multiply. So first row, first column, 1 2s are 2. There is no other elements to sum up, so we'll stop here. First row, first column element is done. First row, second column should be written in the second column element. 1 3s are 3. First row, third column, 1 4s are 4. 2 2s are 4. Next, second row, first column. Second row, second column. Second row, third column. Third row, first column. Third row, second column. Third row, third column. So this is the new matrix which is of order 3 cross 3. Next one. So we have to multiply these two. So now we have first row, first column elements. So 2 1s are 2. Next, plus 3 0s are 0, plus 4 3s are 12. So remember, you have 3 elements in a row and 3 elements in a column. That is why number of columns and number of rows must be same. Then only we can multiply the elements inside it. Now this is done. That is, first row, first column is done. So first row, first column is done. Next we have to take first row, second column elements. So 2 into minus 3, minus 6. 3 into 2, 6. 4 into 0, 0. Next, first row, third column element. So we have to write it in the third column. So 2 5s are 10. 3 4s are 12. 4 5s are 20. Now this is complete. We will move on to the second row. So second row, first column. 3 1s are 3. 4 0s are 0. 5 3s are 50. Next, 3 into minus 3, minus 9. 4 2s are 8. 5 0s are 0. Then second row, last column, that is third column. 3 5s are 15. 4 4s are 16. 5 5s are 25. Next, we are with the last row. So the last row with first column. 4 1s are 4. 5 0s are 0. 6 3s are 18. Next, 4 3 minus 12. 5 2s are 10 plus 0. 4 5s are 20. 5 4s are 20. 6 5s are 30. Now, let us add this. 12 plus 2, 14. 15 plus 3, 18. 18 plus 4, 22. This get cancels, so 0. So minus 1. Minus 12 plus 10 is minus 2. The last one we have 42, 25, 30, 40, 56. Next we have 20, 20, 30, 70. So this is the required product of two matrices. So this is how we had defined here. So the number of columns is equal to the number of rows. Hence we can define the matrix. So next question we have, it's a very important question asked many times in your examinations. If matrix A is 0, 6, 7, minus 6, 0, 8, 7, minus 8, 0. And matrix B is 0, 1, 1, 1, 0, 2, 1, 2, 0. And matrix C is 2, minus 2, 3. Calculate AC, BC, verify A plus B into C is equal to AC plus BC. So first let us calculate AC and BC. Then we will verify A plus B into C is equal to the sum of AC plus BC, which is a distributive property. It's an question for 5 marks question. So you will get one 5-mark question from the operation on matrices, which is very easy, and let us see how to solve this. Now first we need to find out AC. AC means, can we define AC? How many columns we have here? We have 3 columns. How many rows we have? We have 3 rows. So AC can be defined. Now let us take AC. So what is AC? 0, 6, 7. Minus 6, 0, 8. 7 minus 8, 0. Now what is C? 2 minus 2, 3. Let us multiply this. First row, first column elements. So we have only one column. So therefore, first row, first column. So 0 2s are 0. 6 into 2 minus 12. 7 3s are 21. So finished. Because there is no other columns to write different columns. We have only one single column. So therefore, this matrix also has only one single column. Next, we will take this. Minus 6 into 2 minus 12. 0 into minus 2 plus 0. 8 3s are 24. Done. Now the last column here with row, third row. 7 2s are 14. Minus 8 into minus 12 plus 16, and here you will get 0. Let's see. Let's solve it. Minus 12 plus 21. So this is 9. Next, 24 minus 12 is 12. 14 plus 16 is 30. So this is AC. So we have calculated AC. Now let's calculate BC. Let's write BC now. B into C. So what is B? 0, 1, 1, 1, 0, 2, 1, 2, 0. Let's see C. 2 minus 2, 3. Let's multiply this. So here also we have first row into first column. Only one single column will get here. So 0 2s are 0, minus 2 plus 3. Next. 1 2s are 2. So this is the second row, first column. 1 2s are 2 plus 0 plus 6. Next, the last row with the column. 1 2s are 2 minus 4 we will get 2 into 2 plus 0. So when you add it, you will get 1. 6 plus 2, 8. And here it is minus 2. So now we have verified BC. So now let's take AC plus BC. Let's add it. AC plus BC. So AC we got it as 9, 12, 30. And BC we got it as 1, 8, minus 2. Add it. So addition is nothing but corresponding elements. 9 plus 1, 10. 12 plus 8, 20. 30 minus 2 is 28. So let me take this as equation 1. Now, in verification, the right hand side part is done. Now let's see what is A plus B into C. First find out A plus B. So let's see A plus B into C. So let's write A. 0, 6, 7. Minus 6, 0, 8. 7 minus 8, 0. Then let's take B. So B is 0, 1, 1, 1, 0, 2, 1, 2, 0. So this is into C. So C is here 2 minus 2, 3. Let's add this. So A plus B. 0 plus 0, 0. 6 plus 1, 7. 7 plus 1, 8. Now here we have minus 6 plus 1, minus 5. So 0. 8 plus 2, 10. Next, 7 plus 1, 8. Minus 8 plus 2, minus 6. 0 plus 0, 0. Now let us multiply this with 2 minus 2, 3. So first row into first column. So we get A plus B into C is equal to, so 0 into 2, 0, 7 2s are minus 14, 8 3s are 24. So 0 minus 14 plus 24. So first row into first column element is done. Next is second row into first column. Minus 5 to minus 10, 0, 30. So minus 10 plus 0 plus 30. Next, with the last row, 8 2s are 16, minus 6 into minus 2, 12, 3 0, 0. So 16 plus 12 plus 0. Let's add this up. Then we will get here 10, 20, 28. Let me take this as equation 2. So observe equation 1, it is 10, 20, 28. Observe equation 2, it is 10, 20, 28. So therefore what we can conclude from 1 and 2. From 1 and 2, A plus B into C is equal to AC plus BC. Hence, we have proved it. So this is a 5 marks question which is very important, asked many times in the examination. Let's look at the next question. So this is also one of the important questions for 5 marks here. So this is also a question from the operation of matrices. So here we have, if matrix A is 1, 2, 3, 3 minus 2, 1, 4, 2, 1, then show that A cube minus 23A minus 40I is equal to O, that is null matrix. So when you solve this equation by substituting A cube, 23A and 40I, then the resultant matrix must be equal to the null matrix. First, let us find what is A cube. To find A cube, I need A square, because A cube is A square into A. So first let us find out A square. A square is not just squaring the given matrix. A square is again A into A. That is, you have to multiply the same matrix 2 times. So let's see it. So we have 1, 2, 3, 3 minus 2, 1 and 4, 2, 1. And here again 1, 2, 3, 3 minus 2, 1, 4, 2, 1. Let's multiply and add it. 1 1s are 1, 2 3s are 6, 3 4s are 12. Next we have 1 2s are 2, 2 into minus 2 minus 4, 3 2s are 6. Just remember the rule, first row into all the 3 columns, next second row in all the 3 columns, next third row with all the 3 columns. So next we have 1 3s are 3, 2 1s are 2, 3 1s are 3. Next, second row we are taking with all the 3 columns. 3 1s are 3, 3 into minus 2 minus 6, 1 4s are 4, 3 2s are 6, minus 2 minus 4. So here it becomes plus 4. Next we have 1 2s are 2, 3 3s are 9, minus 2 into 1 minus 2, 1 1s are 1. Next we have 4 1s are 4, 2 3s are 6, 1 4s are 4, 4 2s are 8, 2 into minus 2 minus 4. Next we have 1 2s are 2. Next 4 3s are 12, 2 into 1 plus 2 and 1 into 1, 1. So let's see now what is A square. Let's add this here. So 12 plus 6 plus 1, 19. Next we have 2 minus 4 minus 2 plus 6 is 4. 3 plus 2 plus 3 is 8. Next we have 3 minus 6 is minus 3 plus 4 is 1. 10 plus 2, 12. Next 9 minus 2, 7. 7 plus 1 is 8. Next we have 10 plus 4, 14. Next we have 4 plus 2, 6. Next 12 plus 2, plus 1, 15. Now, this is matrix A square. Now, we have to find out A cube. So, for A cube, we need to multiply A square with A. So, what is A square we got here? 1948. So, we'll write it 1948. Next, we have 112.8, 112.8. Next, we have 14,615. So, 14,615. Now, multiply this with A. What is matrix A? 1, 2, 3. 3 minus 2, 1. And the last row is 4, 2, 1. So, the same operation, that is first row into first column. So, 19 ones are 19, 4 threes are 12, 8 fours are 32. Next, 19 twos are 36, minus 8 plus 16. Next, 19 threes are 57, plus 4 plus 8. Next, we have second row with all the columns. 1 ones are 1, 12 threes are 36, 8 fours are 32. Next, we have 1 twos are 2, 12 twos are minus 24, 8 twos are 16. 1 threes are 3, 12 ones are 12, 8 ones are 8. Next, the last row with the 3 columns. 14 ones are 14, 6 threes are 18, 15 fours are 60. 14 twos are 28, minus 12 plus 30. Next, 14 threes are 42, plus 6 plus 15. So, when you add this matrix, we get A cube is equal to 63, 46, 69. And next row we have 69 minus 6, 23. And the next row we have 92, 46, and here we have 63. So, thus we have found A cube. Next we will find out 23A. So, 23A means we have A as 1, 2, 3, 3 minus 2, 1, 4, 2, 1. Just multiply 23 to all the elements inside the matrix. So, we get the value as 23, 46, 69, 69 and minus 46, and here we get 23 again. Next 23 fours are 92, 2s are 46, and next we have 23. So, this is 23A. So, why I need to find out 23A? Because we need the equation A cube minus 23A minus 40I. So, now what is I? So, I is a identity matrix of the same order of A. So, A is an order 3 cross 3 matrix. Hence, we have to take I in the form of 3 cross 3 matrix. That is, I here is 1, 0, 0, 0, 1, 0, 0, 0, 1. And when you multiply 40 to I, what happens? So, 40, 0, 0, 0, 40, 0, 0, 0, 40. So, this is what 40I means. So, multiplying 40 with the identity matrix of order 3 cross 3. Now, let's consider the equation. So, the equation we have here, A cube minus 23A minus 40I. Now, we have to show that the resultant matrix is a null matrix. So, what is A cube we got? So, A cube is 63, 46, 69. 69 minus 6, 23. 92, 46, 63. So, this is A cube minus. So, what is 23A we got? So, 23A is 23, 46, 69. 23, 46, 69. 69 minus 46 and 23. 92, 46, 23. 92, 46, 23. So this has to be subtracted with 40i. 40i means 40, 0, 0, 0, 40, 0, 0, 0, 40. Now let's solve each corresponding elements here. 63 minus 23 is 40. 40 minus 40 is 0. 46 minus 46 is 0 and the rest of the element is 0. 69 minus 69, 0. 69 minus 69, 0. Minus 6 plus 46 is minus 40. So here we have got minus into minus plus 40. Plus 40 minus 40 becomes 0. So again you can see all the terms here result to an element corresponding to 0. So therefore this is equal to the null matrix. So again this is an important question for 5 marks question. So you have to find out a cube, 23a and 40i. Just substitute in the equation and show that the resultant is a null matrix. Next question. If a is equal to 3 minus 2, 4 minus 2, I is equal to 1, 0, 0, 1, find k such that a square is equal to ka minus 2i. So let us find out a square first. A square is 3 minus 2, 4 minus 2 into 3 minus 2, 4 minus 2. So let's multiply this. So here we get 3 3s are 9 minus 8. Next 3 minus 2 minus 6 plus 4. Next 4 3s are 12 minus 2 4s are 8. Next again we have 4 into minus 2 is minus 8 and here it is plus 4. So we have 1 minus 6 plus 4 is minus 2 and here we have 4 and here we have minus 4. So now this is a square. Let us take the equation there. We have a square is equal to ka minus, so we have 2i. A square we got it as 1 minus 2, 4 minus 4. 1 minus 2, 4 minus 4. So ka, here we have k into a. Let's write ka as it is here. So minus 2 into I means what does it becomes? 2002. Because I is 1002, when you multiply 2 it becomes 2002. Now we get ka is equal to, when you shift this matrix here, it will add. So 1 plus 2, 3, minus 2, here it becomes minus 2 plus 0. So 4 plus 0 is 4, minus 4 plus 2, here 2, minus 2. Next here, in the right hand side we have k into a. That means you have to multiply matrix A with k. What is matrix A? It is 3 minus 2, 4 minus 2. When you multiply k, what happens? It is 3k minus 2k and here we have 4k minus 2k. And now 3 minus 2, 4 minus 2. Now here just we need to find out the value of k. So equate here because two matrices are equal. When we say two matrices are equal, when corresponding elements are equal. So just equate any one of them. If you equate 3k with 3, this also implies k is equal to 1. Or when you imply minus 2k is equal to minus 2, this also gives k is equal to 1. Or if you take 4k is equal to 4, this also implies k is equal to 1. Or minus 2k is equal to minus 2. That also implies k is equal to 1. Since here two matrices are equal, we can equate the corresponding elements to find the value of k. Thus what we can conclude, that is the value of k is equal to 1. Next, the last question here. If a is equal to 102021203, prove that a cube minus 6a square plus 7a plus 2y is equal to 0. So here I'll just directly write what are the values of a cube. So when you multiply a 3 times, that is first you have to find a square, then again multiply with a. So then we get a cube is equal to 21, 0, 34. Then the second row contains the elements 12, 8 and 23. And the third row element will contains 34, 0, 55. So this is a cube. Next we need to find out 6a square. To find AQ, we already find A square. So 2A square just multiply 6. And when you multiply 6, the new matrix will be 30, 0, 48. And the second row is 12, 24 and 30. And third row is 48, 0, 78. And clearly, 7A means just multiply 7 to the given matrix. So when you multiply 7A to the given matrix, it is 7, 0, 14, 0, 14, 7, 14, 0, 21. So this is 7A. And the last one is 2I. So 2I. Since all of them are 3 cross 3 matrices here, you have to take I as 3 cross 3 matrices only and multiply with 2. Then it becomes 2, 0, 0, 0, 2, 0, 0, 0, 2. So these are the solved matrices for A cube, 6A square, 7A plus 2I. Then add it. Add means add the corresponding elements of each element, and wherever you need, you have to subtract. For example, if I take the first element according to the given equation, we have 21 minus 30 as minus 9. Minus 9 plus 7 is minus 2. Minus 2 plus 2 is 0. Similarly, for each corresponding element, subtract A cube from 6A square, then add 7A, then add 2I. So the resultant matrix will become 0. Hence, by substituting all the values in the given equation, the resultant matrix will be null matrix. This is also an example for 5 marks question. So where you have to find the values of all these and just substitute inside the equation. So this is all about the multiplication of matrices. We'll meet you in the next session with the new concept of matrices. Until then, keep watching, keep learning, keep exploring. Thank you.